What do I have to go onto?
You just gotta wait for it to load. It still says
All right,
waiting.
this is what happened last time.
Yep, it still says waiting, and I'll tell you as soon as it's good. And now I think we're good.
Okay.
Just wanted to add that picture. Now we're good.
So if I'm in YouTube on your channel, what do I have to do?
What do you mean?
Or will you just pop up?
It should pop up with the live lesson.
Okay.
Big emphasis on should. Yep, it says live now, so you should be able to get on if you refresh it.
Okay.
Hey, Mr. Parks, welcome back. How you doing today?
I'm not seeing it yet.
No?
No.
Huh. I'm tired. That stinks. Yeah, if you just search my name, it should or oh, how about this? I could take the link and then I could go into our chat and then I could post the link.
Oh wait, I got it. It popped up.
Okay. Yeah, sometimes it's a little pain. A little bit. Oh. There we go. We got 4 people.
All right, so the volume's off, so I leave it off, right?
You leave it off on YouTube and then you just talk to me and we'll be all cool.
All right, awesome.
Oh, did something happen?
I don't know.
Oh, no, there you go.
Okay, here I am.
I can't minimize your link, otherwise you go away.
That's funny.
It's a learning process for those of you out there. It's not easy to get all this crazy tech nonsense all working. Ooh, 7 people. Howdy, folks.
I see 8. Well,
You see
I'm probably
8.
one of them, right?
No,
I'm
I see
probably
8.
Okay.
We'll give it another minute. But anyway, folks.
Happy Monday.
Yeah, happy Monday. Good thing that like maybe we'll have some structure and know what day it is. I'll be honest, I had no idea if it was Tuesday or Thursday about a week ago.
No, me neither. This might definitely will give us more structure.
For sure. So anyway, folks, let's jog that brain. If you're coming in here now, you got a question on the board, screen, whatever you want to call it. Answer the following: why do streams meander? Let's see it in the chat. Let's get some chat involvement. Just like type it, but don't hit enter yet. Ooh, let's do that. Type it all out, and then we'll give you like a 3, 2, 1, and then everybody hits enter. We'll read some off.
Hopefully you remember what meander means.
Ooh, that's true. But you do have a nice big clue in that animation right there. Or GIF, or whatever you like to call it. It's not really animated, that's real. So. while you're writing this, on the bright side, it's a nice sunny day as opposed to all those cloudy days we've been having the last few, right? It's been like rainy and cold and muggy. It's finally like you might be able to go outside on, your backyard and kind of hang out.
Yes, we're having mandatory yard work today.
Excellent.
After my kids do their schoolwork, they're going outside to do some yard work.
Good. Yeah, get some fresh air. We've all been cooped up for way too long.
Yes, absolutely. Technology break today. All right, we ready for some responses?
I think so. All right, folks. Hit enter. Hopefully you have something written down. Answer the following. Why do streams meander? Let's go.
No one?
It's taking up a second. There we go.
Cordelia. Hi, Cordelia.
Hey, Cordelia. Okay, cool.
That's a good answer.
Well, Mr. Parks, you can't be this tired. Come on, man. You could be watching this in bed for all we know. There we go. When erosion and deposition occur, the soil goes to the inside and the outside curves larger and larger. Okay, Mr. Parks, but that's a good answer. Yeah.
I'm like in the Mario.
Oh, yeah. For sure. I figured. Hey, I'll be honest. I took a class in college that I could do all online, and it was definitely done from bed. That's how that worked.
It's probably the most comfy place to be.
Absolutely. Plus, it's like a nice little private spot. You can close your door. You can really focus. I don't know. It's a lot of benefits, I think. Well, we got 2 of 10. Anybody else with an answer?
Ashlyn, do you have a meandering answer?
Fair enough. Well played. Well, you guys will be doing an assignment later, so we'll definitely get some more answers out of you. Just trying to wake everybody up, get them involved in the chat. But anyway, we're going to move on. Today is going to be very, very short in terms of what we're talking about. We're just coming off of talking about erosion and deposition within the 2 different curves. The last time we met, we talked about the channel and how it builds up on one side, gets eroded on the other. So today we're going to spend some time looking at what actually is involved in the movement of these things, right? Where is all that sediment in the stream? And then also what happens when the stream stops, right? When this stuff gets deposited, how does that work? Is there a way that it works? Is it completely random? That's what we're going to see today. So, where is all this moving sediment in the stream is the first question. We've been looking at the stream velocity graph, and we know that streams can move different size sediments. So, where is it though? Like, if you went to a stream, you don't just see like sand flying around. So how does that work, right? Does it float at the top? Does it sink to the bottom? Is it a weird combination? That's what we're going to take a look at. How delayed is it for you, Astramovich?
Probably a good like 20 seconds,
Oh,
I'm
really?
guessing, based on like I can see you talking, but I can't hear you, and then I hear you.
Interesting. Maybe if you refresh it, it'll be like more.
Okay, let me do that.
Oh, hey, Egan. Yeah. Here, just to give you an indicator of how slow it is for you, I'll just like raise my hand, and then I'll put it down.
It's still refreshing. Oh,
Oh.
it's still refreshing, and then it did it again by itself. So I didn't
Interesting.
even see you raising your hand. See you raising your hand.
Well, we'll do the best we can, folks. It's not a perfect system. We're trying here.
No, as long as they can hear both of us in real time, then I guess it's okay. We'll make it work on our end.
True. All right. So, stream load, the material that a stream carries. Materials can be carried by 3 different primary ways. So the first one is in solution. So that's like if you take your lemonade powder and mix it in with the water, eventually it is in solution. It's dissolved into it, right? So you get lemonade from that. So the same thing happens with certain things, certain particles, and the stream. So like let's say if you have salt, that's not going to be in like little salt crystals jumping around. It's going to dissolve and then get carried that way. The second type is suspension. So these are going to be in that bottom part, this, well, not the bottom part, but lower down, you see where it says suspended load. That is going to be flying around. You can think of the word like suspenders, right? What is that? They keep your pants up. So something in suspension is kept up. It's not at the bottom. It's floating, so to speak. So these would be the finer sediments of clay and silt, the smaller stuff that can more freely float, or it takes a long time for them to actually like settle. And then the last form is, or method is saltation. So this is bouncing or rolling, and you can see there are a couple arrows showing down here on the bottom of things kind of arcing and going across that bottom part. So that is on the bed load. The bed is the bottom of the stream, and they kind of just roll over each other. So those are the 3 ways that these sediments are actually being transported.
Any questions with that so far?
All right. Fair enough. So we've been looking at weathering, which is the breakdown of rock. Then we looked at erosion, which is once you have the broken down rock, it gets moved from one place to another. Now we have deposition. So what is the exact definition of deposition? It is the release of sediments in an erosional depositional system, also called sedimentation. So the release, they're saying, or instead of release, you could think of it as just like dropping it. Right? It's the drop off of these sediments from one thing that was moving it to now some, place, just like the ground or in the bottom of a stream. So it's these sediments finally falling, being like, think of deposited at a bank, right? If you deposit money at the bank, you're leaving it there. The same thing happens with all these sediments, right? They're leaving the sediments somewhere. So erosional depositional system, that was part of that definition. What exactly is that? That is talking about these meanders where you've got the outside getting eroded and the inside getting that deposit of sediment. So it was talking about primarily streams. And here it says the meander widens from erosion on the outside, deposition on the inside. The 2 sides of the meander erode into each other. Water slows in the inside loop, causing deposition. And then if it gets squiggly wiggly enough, the loop gets cut off in an oxbow lake, which we have a picture of in the bottom right, while the stream returns to a straighter course. So you can get these kind of cool horseshoe looking lakes that are not long lived, but they will exist for a small time once these loops get cut off and the water supply just kind of stays there. Any questions with that?
Anybody want to summarize what Mr. Dupre said? Guys, good? You want to move on? You have any questions? Let us know.
Yep, it's just like class. If you don't say anything, we just keep going. So, we're happy to stop. We've got the chat. All right, fair enough. So, when a river enters a lake, what happens to the water's velocity, and how does that affect what it can carry? What do you think, folks? So, when you have a river going into a lake, what happens to the velocity?
Type that in now. Come on, guys.
Oh, man.
When the river's flowing fast, like you see on the left, and it enters the right, what happens to the speed of the water?
Okay. What happens to the velocity? It decreases. We got one vote for decreases. Okay, cool. Good, yep. So it's going to decrease the velocity. Velocity is just like speed. Good. So how does that affect what it can carry then, right? The stream is carrying some sort of sediments. When it slows down, what happens to how much it can carry? Does it increase or does it decrease? Cool. Yeah, definitely it's going to have less. So once you have this stream that's going to hit some body of water, and a lake will be basically not moving at all. It might have a small amount of movement. Yeah, definitely won't carry big stuff. And this also happens in the ocean too. Even though the top of the ocean moves a lot with waves, the water that is underneath the waves doesn't really move all that much either. So when a river enters either a lake or the ocean, it's going to drop what it's carrying. So that leads us to this picture here, which was hand drawn by someone who has definitely better handwriting than myself. The deposition is when the river enters a lake or ocean, the velocity is going to drop very quickly, and that means that this says depo, as in deposition, occurs according to size, shape, and density. So for one of the classes, I think it was my period 3, we did the deposition lab together, but for the period 8-9, we did not get a chance to do the deposition lab. So we did actually get to play with size, shape, and density. But what you have to know is all listed right here. So first, the stuff that drops the first, the fastest, is going to be the stuff that's large, more dense, and more round. The stuff that's going to stay suspended, right, or like floating, not falling so quickly, the stuff that drops last is going to be the smallest particles, smallest sediments, the least dense, so it's not that heavy in your hand, right, and then the flattest. So you could even do this at home with like a piece of paper with the size. It's the same thing as, where do we write this? If you really wanted to, you could use your notes packet later and go through. We do have these notes posted on Mrs. Astramovich's e-board if you just wanted to like have them completed.
Yes, it won't look exactly like this. It won't have all the pretty pictures and stuff like that, but the notes themselves are there on my e-board.
Yep, and don't forget, when the live stream is over, you can go back and watch this video all day, 100 times. No, I'm kidding, but you can watch it if you miss something or if we say something too quick. So you do have that. Going back to what I was saying before, if you take a piece of paper, right, just a regular piece of paper, and you let it drop, it's going to do that thing where it goes back and forth and falls really slowly, right? But if you take it, you crumple it into a really, really tight ball, and then you drop it, well, it's the same piece of paper, should have the same density, it's the same size. The only thing is you made it, flat to round, and you'll see that it falls way faster. So that is kind of the same thing between the flat and round particles that we have listed there. So the other thing that you get from this is you get this pattern right here. So if you see that right at where it says river flow and it enters into that water, the first stuff is going to be really big. And as you go away from where that river actually is, whoa, it's a loud car. As you go away from where that river is, you'll see that the stuff gets smaller and smaller and smaller and smaller and smaller, or I guess it would be for you guys like this way. So it starts off over here on that far side, really, really big. You could see the circles we did where it says depot first. They're like huge. And then it gets smaller and smaller, smaller, until you get only like the clay left over. So that's another thing that you might be asked to do, is to answer a question or maybe even draw where that big stuff is versus where the small stuff is.
Just always keep in mind, big stuff drops first and it gets smaller as you get further out into the stream.
All right. So that's it for today. We just wanted to talk about deposition. Again, there's going to be an assignment posted at some point today, probably around 2 o'clock-ish. So be on the lookout for something in Google Classroom. Also, there was an error with the previous assignment that I changed the date. I gave a little bit more time for it, and somehow it seems like some people had their assignment unturned in. Sorry about that. We're still learning the systems here, so don't worry about it. We have your answers and whatnot, but just make sure you're answering it before the due date, because I know some people are just finding out about Google Classroom and that everything's being posted there. So just be on the lookout, folks.
Yeah, keep in mind that quarter 4 starts today, so everything from this point forward is being graded and counts for quarter 4.
Yep.
Mr. Dupre, we should also probably mention our office hours for anybody to reach out to us if you want to meet with us either in a small group or individually for some extra help.
That
Mr.
is-
Dupre's times are earlier than mine, so I'll let him go first, and then we can get into my hours.
So I have, hold on here, distance. Here we go. So I made a calendar that a lot of you guys saw that I put on the Google Classroom, and it shows all of our time slots. So if you didn't get a chance to see that, I have it listed by increments of half hours. So 9 to 9:30 is like my APES class. If you look at 11 to 11:30, that's usually when we're going to do YouTube lessons for Earth Science. I have a little bit of extra time blocked off in case we wanted to do a practice afterwards, so 11:30 to 12. And then you could see the office hours for us basically are from like 12:45 to 2 o'clock. My office hours being in these boxes, and then Astro has her office hours 1:30 to 2 right here. So if you guys needed to know when office hours, when we're meeting, all that stuff, it's listed right in this calendar, and I posted that on Google Classroom.
And if you guys, if anybody does have questions and you want to meet like this, just shoot either one of us an email or both of us, and we can meet with whomever feels like they need some extra help.
Yep. So we'll be available. Are you gonna post your Google Meets in the Google Classroom? Like the link so that they can get to your office hours that way, or?
If anybody wants to specifically meet with me, I would say the best thing to do is to probably shoot me an email.
Okay, the email. Sorry, that's what you were just saying. Yeah.
Yeah, and then I can send an email to them with the link to meet me.
Gotcha.
In there. That way, that's probably the easiest way to do it. Whether it's, small group or individual, I would think, unless you have a better way to do it.
Oh, no, it's not better. It's just I was going to post my link in the classroom itself. But either way.
I think either way is probably fine.
But yeah, if you're going to come to the office hours, maybe an email just to give us a heads up.
Yeah, that way we would know who's coming, how many people, and we can set it up.
Yep.
To make sure that everybody's involved. Again, not mandatory. It's just like regular extra help. It's not mandatory, but especially now, if you feel like you're not understanding this stuff as we move forward, make sure you reach out to us, and we'll be there for you.
That's also another good point. These Earth Science lessons, they are mandatory, right? So if you're watching this afterwards, we did it live, that's fine. But just make sure that you stick with it, because this is our regular classroom experience. So it's not anything that we can really know if you're watching or not, but definitely keep on top of it, because this is how you're going to get what you need to get. So, all right. Is there anything else?
Before we head out for the day, guys, let us know if you have any questions.
Yeah, we'll stick around in the chat for one more minute or so. Yeah, feel free to email either of us. There will be more work. We're going to post something at around 2. So just, in a couple hours, take a look. It'll be on Google Classroom. Yep.
Any other questions?
All right. Well, I guess if you have a question, just our office hours just used for yes. Think of it like an extra help or like just like extra one-on-one support. So totally optional. If you feel like you're totally good, then you don't necessarily have to come, but we'll be hanging out ready if you have any questions at those times. All right, folks. Well, we're going to end the stream there. If you have any questions, email us. Have a good day.
See you guys Wednesday.